This lesson covers some more material out of Unit 7-8, still working with linear relationships. This material is from Box E and Box G. We're going to talk about lines of best fit and curves of best fit. And as we do this, we're going to also talk about the difference between linear and nonlinear relationships. So before we do this, let's just talk about relationships. And this is why we actually make scatter plots. We use scatter plots to show the relationship between our two variables, or our two things that are being plotted. So on this graph on the left, what kind of a relationship is being shown, or what are we looking for a relationship between? Well, we find that information by looking at the labels on the x and the y-axis. Down on the x-axis, we have latitude. On the y-axis, we have temperature. So we're looking for a relationship between temperature and latitude. So our graph shows temperature versus latitude. This graph over here on the right, we've got height on our y-axis, time down on our x-axis. So the title here says we're looking at the path of an arrow, but what this is showing the relationship between is the relationship between the height and the time, or we're plotting height versus time. If we look a little bit more closely at these two graphs, we'll go back to the temperature and latitude graph on the left here. And what it says down here at the bottom is that on this graph we can draw a straight line that follows the trend of the points. Now, if I take my, my straight line tool here and I get myself a straight line, I can draw a line kind of like this. Now notice that it doesn't go through every single one of the points. There's some points above it, some points below it. But what it does is it shows sort of the general path that these points sort of appear in. So this follows what we call the trend of the points. The points tend to go downward as we go from left to right on this graph. That's our trend. And they seem to follow this straight line that I've drawn on here. So because I could draw this line, what this line is called is a line of best fit. Because it's the straight line that is the best fit to the data points, or the trend of the data points. Since we can draw a line of best fit to this graph, we can say that the relationship between temperature and latitude is a linear relationship. Okay? Linear just meaning that this relationship, or this trend, is kind of in the form of a straight line. Now let's go over to the graph on the right here, where we're looking at the path of the arrow. Well, if we want to draw a line that's going to follow the trend of these points, we can't draw a straight line. We have to draw a line that curves up and then comes back down like this. And this time it's actually possible to draw a curved line that goes through all of the points. So on this graph, to follow the trend of the points, we need to draw we'll just say we had to draw a curved line. Okay. This curve is called, well, it's not a line of best fit, but instead it's a curve of best fit. So it's the curved line that best illustrates the trend in the data, or passes close to most of the data points. Now, on the graph on the left, we said it was a linear relationship because we could draw a line of best fit. Since we can't draw a line of best fit, the graph on the right, the relationship is not linear, or we say it as a non-linear relationship. Okay? So the way to distinguish, to tell the difference between whether your relationship is linear or non-linear, is to see if you can draw a line of best fit. Line of best fit means it's linear. If you have to draw a curve of best fit, that means it's non-linear. So let's take a look at the two examples on the back of the page here. Here's the first one. The graph shows the relationship between the life expectancy and the resting heart rate of several mammals. We've got expectancy on the y-axis, resting heart rate down on the x-axis. We want to draw a line or a curve of best fit. Well, let's look at our graph here, look at our points, and decide, is it possible for us to draw a straight line that sort of follows the trend of these points? And I think it is in this case. If I get my straight line tool out, I can draw a line that kind of goes like this. Again, it doesn't pass through all of the points, but it kind of shows where the general trend of how these points are going. So if we can draw a line of best fit to these points, is our relationship linear or nonlinear? Well, it's going to be linear because we drew that line of best fit. Now we can use this line of best fit that we've just drawn to answer some further questions. Question C here tells us that a giraffe has a resting heart rate of 75 beats per minute. We want to predict the giraffe's life expectancy. This is similar to the interpolation and the extrapolation that we did in the last lesson. So we find 75 beats per minute. Well, that's going to be a resting heart rate. So it's down on the x-axis, so we want to find 75, which is going to be halfway between 50 and 100. And we go up to the line of best fit, and then we go across to estimate what the life expectancy is going to be. So we seem to be a little bit above 20, the low 25 there, so let's say that that's about 21 years. Now we use this line of best fit because we didn't have a point or data point that corresponded to a resting heart rate of 75. If they had asked us about, say, a resting heart rate of 50, they would be referring to a specific data point, probably this one right here. So if we went up like this, we got to that data point, we would probably go across like that and estimate what it is. Okay? But if we don't have a data point right there, instead we use the line of best fit that we've just drawn. Let's get rid of that red stuff there. Okay. So let's take a look at the next example down below. In this situation, we're told that the money a person pays for a life insurance policy is called a premium. The premium depends on many factors, including how much insurance you want and your age. The monthly premiums that one company charges for $50,000 of life insurance for a male smoker are shown on the graph. So this shows the relationship between the monthly premium that they would charge, or the amount you'd have to pay each month for life insurance, and your age in years, or how old you are. Part A asks us to draw a line or a curve of best fit. Now, is this going to be a line or a curve? Well, I think in this one we can draw a curve of best fit. We can draw a nice smooth curve that goes through all the points. And I'm going to extend my curve all the way to the edges of the graph, okay, because I'm assuming that that relationship exists even in those points that aren't plotted. Now, I drew a curve of best fit. So is our relationship linear or nonlinear? Well, if we had to draw a curve, it's going to be a nonlinear relationship. And then we have some questions that were asked based on this graph. Estimate the monthly premium this company would charge a 65-year-old male smoker. Well, we want to find 65 years on the graph. So 65 would be right here. And then we want to go up to our line of best fit. And then we want to go across to estimate the premium. So we're going up and across. And that looks like the premium would be about, I don't know, a little bit above 120, so maybe $122. Part D asks us, at about what age would a male smoker's monthly premium be $40? So we want $40. They're giving us a value for the premium. So if we go to the axis where premium is plotted, we find $40. And we go across to our curve of best fit. And then we go down. And this looks like we're a little bit above 50 years, not quite to 55. So maybe 52 years. So 52 years. Okay. So in our example in part C, we were using extrapolation because we were working beyond the data points that were plotted. In part D, we were working on interpolation because we were inside the data points that existed.